Welcome to this video on the fundamental concept of light in physics. Today we'll explore what light is, its wave nature, and where visible light fits in the broader electromagnetic spectrum. So what exactly is light? Light is an electromagnetic wave. An electromagnetic wave consists of oscillating electric and magnetic fields that propagate through space, even in a vacuum. These waves carry energy and momentum, and they don't need a medium to travel through. Let's visualize an electromagnetic wave. The blue wave represents the electric field, which oscillates in one direction. The red wave represents the magnetic field, which oscillates perpendicular to the electric field. Both fields are perpendicular to the direction of wave propagation, which in this case is along the x-axis. This is what we call a transverse wave. The wave has properties like wavelength, which is the distance between consecutive peaks, and frequency, which is the number of oscillations per second. The product of wavelength and frequency equals the speed of light. Now, visible light, the light we can see with our eyes, is actually just a tiny part of a much broader electromagnetic spectrum. The electromagnetic spectrum includes all types of electromagnetic radiation, arranged by wavelength and frequency. It ranges from radio waves with the longest wavelengths and lowest frequencies to gamma rays with the shortest wavelengths and highest frequencies. Visible light falls in the middle of this spectrum and represents only a narrow band of wavelengths from approximately 400 nanometers violet to 700 nanometers red. Let's look at the different types of electromagnetic radiation in order of increasing frequency: radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and finally gamma rays. As we move from left to right, from radio waves to gamma rays, the wavelength decreases while the frequency and energy increase. It's worth noting that light exhibits a fascinating dual nature. Sometimes light behaves as a wave, as we've discussed, but in other experiments, light behaves as if it consists of discrete particles called photons. Each photon carries a specific amount of energy that depends on the frequency of the light. This is expressed by the equation E equals h times f, where E is energy, h is Planck's constant, and f is frequency. Let's wrap up by looking at some practical applications based on different parts of the electromagnetic spectrum. Radio waves are used for communication, from radio broadcasts to cell phones. Microwaves are used in microwave ovens and also for communication. Infrared radiation is used in thermal imaging cameras and remote controls. Visible light allows us to see and is used in countless technologies, including fiber optic communications. Ultraviolet radiation is used for sterilization and in black lights. X-rays allow doctors to see inside the human body, and gamma rays are used in certain cancer treatments and for sterilizing medical equipment. To summarize, light is an electromagnetic wave consisting of oscillating electric and magnetic fields. Visible light is just a small part of the electromagnetic spectrum, which includes radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Light demonstrates a fascinating dual nature, behaving both as a wave and as particles called photons. This understanding of light has led to countless technologies and applications that we use every day. Thank you for watching. If you have any questions about light or the electromagnetic spectrum, feel free to ask.